There we go. Gotta love the delay of going live on different streaming platforms. But here we are. So I'd like to welcome everyone that's out here. Looks like we've got 15 or so of us. Kyle, Steve, James, Majog, Gregory, Don, Richard, Doug, Hundra, Jay, James, Andrew, Jay, Hafiz, I think, and Dylan. I'm sure we'll get more people as we go along. But glad to have everyone out here. So tonight we've got some interesting stuff talking about what's going on in Java since Java 11. So we're covering features from Java 11 all the way up to current Java 17. And should be really good, especially if you're still stuck on Java 8, which I know a lot of people are. So it should be good, things that you can look forward to, maybe things you haven't heard about, or things that you're looking forward to using. If you've got questions or comments, feel free to use that chat box over there on the right side. Questions down at the bottom. You can use the Ask a Question down here, and we'll cover with those. So we've got Steve with us, and he's going to present. I'd like to give a shout out to our sponsors. I don't believe we have any of them here with us tonight. We don't have a sponsor speaking, but again, the sponsors, great to have them. They allow us to keep doing this every year, and at some point in time, we will be back in person, hopefully, and we'll be back over there at Lucid, unless they decide not to, and we'll go back to the way that things used to be. Definitely looking forward to that. We would love to hear your comments if you're interested in getting back in person, and we'll continue on with that. Let's see, stuff coming up. So next month we have Garrett Grunwald, who's going to be talking about Project Crash, or sorry, not Crash, Crack in the JVM, which is coming at some point. I don't know which Java version it's slated for, but it deals with startup times and whatnot. So trying to decrease that startup time and give you better performance all around on the JVM. At the end of the year in November, because we don't do meetings in December. In November, we have Jeremy Davis speaking from Red Hat, and he's going to be talking about majestic monoliths. So kind of the inverse of doing the whole microservice approach that everyone hears about. So he's going to be talking about why monoliths are sometimes the right way to go, or why you would want to use one versus going to microservices and all that kind of stuff. So definitely looking forward to the next couple of months, and we'll finish out the year with that. And then we've got some great stuff coming for the start of next year, but we'll get into that as we get closer. So without any further ado, I will bring Steve on and we'll get things going. And again, if you've got questions or whatnot, feel free to use the Ask a Question or down in the comment section as well. If you're watching on YouTube, I'm going to be bouncing back and forth here and there, but I can't promise you that I will get to your comments in a timely manner, but I will do my best to get to them. So here's Steve.
Hey, everybody. Thanks for taking time out to check out this presentation tonight. Obviously, we're talking about the latest long-term support version of Java 17. Actually, Java 18 is already out, and Java 19 will be coming out soon. They have a pretty good cadence going since they developed this new release schedule. But instead of just talking about, specifically the interim versions, I just want to talk about going from the long-term support and specifically from 11 to 17. Me personally, I am using Java 11 at Master Control where I'm employed, but we do have another team, another product that's actually already on Java 17. And some of the features, as we're going to talk about tonight, are pretty cool. I'm really excited to be able to get our product to upgrade from Java 11 to 17. If you guys are, if you're still on Java 8, I'm sorry. Hopefully most of you are on Java 11 already. And if you haven't played with Java 17, you'll find out in this presentation, there's an actual repository I provided on GitHub. You're free to clone it and play around with all the Java 17 features in your local environment, which is a great way to get familiar with the new features if you're not already using it for work. So about me, I've worked in a bunch of different industries. I've been developing. I I'm a veteran, so I did my military service first, then I did college. So I entered commercial industry in 96. And some of my favorite things I love to do, obviously, I'm passionate about software development, and I spend my personal time doing that as well as obviously professional time. I also am a big movie buff. The last movie I saw in the theater was Bullet Train, Brad Pitt movie, really good. Last movie I saw at home was an Amazon original called 13 Lives about the Thai boys soccer team that got trapped in the caves. And it was a herring rescue. Ron Howard was the director, and I highly recommend it if that kind of thing interests you. I'm an NFL fan. I lived in Seattle for 10 years. So, and our first game was for the new season was this past Monday night. I was thrilled with that. Trivia, food. I'm a foodie, love going to new restaurants and trying dishes and stuff. So I have a lot of passions outside of software development. But if you want to find me on GitHub or on Twitter, I have some links here. I haven't talked with Jason yet, but Jason, after the presentation's over, I'm sure you have some way to help me share this presentation. This presentation is meant to be shared with the audience so that they can flip through it if they wish. So any of the links that you see, like here, you'll have those available when the presentation is available to you following tonight. So what we're going to talk about tonight, 3 main sections. We're going to talk about the non-demoable features, and they actually are demoable, but in order to demo them, I would need to have profilers to show what the garbage collectors are doing and all that, and that involves a little bit more time to set that stuff up and go through it. And I didn't want to spend a lot of time on those features because while they're good features to know about and be aware of, they're not as cool as the demoable things that I actually have in IntelliJ to share with you, which is the actual language features. And then we'll just do a little brief thing at the end, talk about what's coming, things we might see in Java 21, which will be the next long-term support that will be coming out next September. So one of the things I love about the Java ecosystems, they're constantly working on lots of really cool things, lots of people contributing to the enhancement of the language. So we'll just cover a little bit about what's coming. For the non-demoable features, the first thing I want to talk about is strictfp. Those of you who are around with Java in the very beginning in 1997 and 98, strictfp was not in the original language. It wasn't introduced until Java 1.2. And the reason for it was because there were precision errors in floats, which are 32-bit.
Hey, Steve.
Yes.
We've got people asking about slides. Are you doing slides and we just haven't seen them yet?
Oh, I am doing slides.
Oops.
And
all right.
Why are they not showing up?
Probably because you're not sharing your screen anymore.
Oh, okay.
Sorry about that, everyone. Nothing like doing it live.
Sorry about that. So, okay. Hopefully, this is going to work even better. Let me get here. Okay.
There we go.
Good. Thank you for catching me on that and keeping me honest.
No worries.
So, yes, these are the slides that I'm going to ask Jason to help me share with you guys afterwards. This is where you have links to my GitHub. Oops, let me get back there. To my GitHub and to my Twitter if you want to connect. That's all cool. Just a little bit about me. I just talked about all that stuff. And then obviously the overview of what we're doing tonight. So the non-demoable features. So strictfp, as I was saying, was introduced in Java 1.2 back in December 1998. And the purpose of it was because we had inconsistencies between different machine architectures and different JVMs. Strict IEEE specifications for floating point operations, obviously floats are 32-bit, doubles are 64-bit floating point numbers. but there were small errors in precision. And by introducing the strictfp keyword into the language in Java 1.2, they were able to say, hey, we're going to go strictly by the IEEE rules. Well, in Java 17, that has now actually been removed. Strictfp is no longer necessary in your function definitions. Every function that's using floats or doubles and doing math operations is strictfp already by default. So there's no need to have the keyword. It has been removed. One of the things you will find with all the features that I talk about tonight, whether they are demoable or not, they do have a link to the to whatever project introduced the idea for it and talks about the need for the feature. And then also I go to Baodong. I love Baodong. As a developer, I'm constantly looking things up in Baodong for how to do stuff in Spring or Java, or how to use this framework. And so I often put the links to Baodong in here as well. So there's a lot of opportunity for you when you go through the presentation on your own to take those links and see, whatever more information you might want to dig in on your own. Garbage collection. We know it's super important. We generate lots of objects, and we especially want the short-lived objects to be quickly cleaned up. In Java 12, on our way from 11 to 17, it was an experimental thing, but they introduced the Shenandoah garbage collector. They wanted to reduce the pause times when doing the cleanup work. And so it's a low latency garbage collector, a low pause time garbage collector. You don't want to have significant pause times during execution of your software for the garbage collector to do its work. And the Shenandoah garbage collector was an attempt to do that. And they've had some pretty good results with that so far. The Z garbage collector is your low latency garbage collector. And here what's going on is this came a little bit later after Java 12. It was experimental in 13 and 14. They kind of finalized it in Java 15. But what they were doing is saying, hey, we clean up these objects, but the heap space is still consumed. The operating system doesn't have use of that space. And they're like, we should probably be good citizens and return the unused heap space back to the operating system. And so the Z garbage collector is an enhancement to do that. I don't spend a whole lot of time on the garbage collection. I don't do a whole lot of heavy math things where I'm doing floating point stuff, but I love keeping up with the fact that these guys are constantly working at all these improvements in every version of Java that keeps coming out. It just keeps getting better and better. And it's just interesting to me, all the under the covers work that is being done. So now we get to demoable features. And this is the last slide we're going to see in the presentation before I bring up my IntelliJ environment. The only thing, so the link up here, if you click on that link, it'll take you to my GitHub repository. You can clone that. I made it free, publicly available. And it has a README for the whole project, but it also has a README for each of the modules. So the things that we're going to talk about, there are obviously a ton of things that were introduced from Java 11 to 17. I cannot talk about all of them, just simple time limitation. But what I did want to do is hit the main highlights of things that you may want to take advantage of when you go from 11 to 17, things that I thought were kind of cool. And these are the main things. And I'm just going to kind of go through them in order, top down, alphabetical order. Seems the easiest. So with that said, I'm going to bring up my IntelliJ environment. And I want to first start on my README. And I want to bring, let's see, where's my... There, this is the pretty version of my README. So this is for the entire project, and it just talks about what this project is about. And as I mentioned, we're just going to go down through these modules in order. So the first module I have selected on the side is the days period module, and it has its own README. So I'm going to bring that README up to talk about what this feature is. And all the READMEs for each module will kind of follow this format. So the days periods support, what the heck is that? I had no idea when I heard it. It didn't make sense to me. I had to actually think about it a little bit, but they do a nice job explaining what it is. So this was actually the only one that was not a Java enhancement proposal. It wasn't a JEP. It was actually a JDK like fix to the language. There was a request to fix it. And it was introduced in Java 16, so it's pretty new, but it's a precursor to the bigger CLDR. What is CLDR? The Common Locale Data Repository. It's its own separate project where they handle a lot of internationalization for things, and it provides key building blocks for software supporting the world's languages. What a days period actually is we're familiar with date time format, and we can provide an AM or a PM when we use 12-hour formats. A days period, we don't talk about AM, PM in normal language. What we might sometimes do instead is say, at 12 noon, we're going to do this, or at 5 o'clock in the morning, this is going to happen, or 6 o'clock in the evening, or 11 o'clock at night. So a days period is the actual language around certain times of the day. So we talk about, the AM PM pattern symbol is an A when we're using date time patterns. It's in the date time formatter class, which was introduced in Java 8 as part of the date time API. But this goes beyond the days periods. It goes beyond AM PM. It uses a B pattern. The capital B is what invokes this time change. So for instance, we can talk about the day period being midnight. Midnight is exactly at 12 a.m. Noon is exactly at 12 p.m. These rules are actually encapsulated in a class that's buried deep down in the Java code. You can customize this stuff if you choose. It gets a little bit complicated if you want to do it. But by default, if the question you're wanting to ask is what's considered morning, what's considered afternoon, I went ahead and looked that up for you. And these are the answers for what morning, afternoon, evening, and night are. Also, because it's internationalized, I do explain a little bit here. Since I'm American, I use the English US locale. But if you speak another language, if you're familiar with other regions of the world, you can get this in French, Spanish, Russian, whatever. It is internationalized if you use that capital B in your formatter. So let's jump into our first code example for the night. And this is my daytime example. And all I've done here is I set up my logger and I set up specific times of the day as just static, as constants. And then the next thing I do is I use my datetime formatter. I use the A for the AM PM, but I also want to see the same output with this B as an alternative. And so I have the usual time pattern. This is what we're already used to from Java 11. But now I see the new time pattern. This is what we get to use now in Java 17. And then there's this log message for time. And so when I come down to, here's my main method. This is what we're going to execute in just a second. You can see that all I'm doing for my log info is I'm saying, here's a log message for time. This is my date time pattern. And then I'm formatting for the different times of day. So we're going to see the format in the usual time pattern for midnight, the new time pattern for midnight, the usual time pattern for noon, the new time pattern for noon. Nothing fancy, nothing glamorous about this. Really simple code, but it's just really neat to see this B pattern in action. So when I run this guy, the output. And by the way, I am using Gradle, so I have Gradle dependency files to maintain. If you prefer using Maven, you're welcome to change. Once the product's in your environment, you can do whatever you want with it. I just happen to like Gradle. I think Gradle is really concise and easy to use. But the output that we get, you can see 12 a.m. is what we would be used to seeing, but it's really neat to see now the time is 12 midnight. The time is 12 p.m. The time is 12 noon. So this is what your day's period does for you. 9:15 in the morning is 9:15 a.m. actually turns into 9:15 in the morning, 5:40 in the afternoon, in the evening, and then they don't say in the night, they say at night. I don't know French. I don't know Spanish, but if you do, I'm sure that the phrases that they're putting in here, when you use those languages and those locales, are translated properly for those languages, that it will sound right if you are native to that language or if you understand that language. So I think the B pattern is really cool. One of the things that I thought was neat was that this is a precursor to bigger fixes that they're going to do in Java 19. So it's already planned. They're working on it. I don't know a whole lot of details, but if you go to the CLDR website and the README has a link to that, you'll be able to find out more about the days periods support. So there's our first new feature in Java 17. This one I really like, the null pointer exception enhancement. So this was introduced in Java 14. This was one of the Java enhancement proposals. And then here's my Baodong article that talks about it. And essentially the problem is when you have multiple values that are being passed into an API, you can obviously get a null pointer exception all over in the code. We've all seen it. The problem is when you're on a very specific line in Java and you get your null pointer exception, up until now, it just says null pointer exception. You don't know where on the line that null pointer exception that happened. You don't know which object to look at. So what do we do as developers? We write logging statements. We have to look at each individual object. We have to look at the return values that we get back from our objects to figure out what was the null thing. Maybe we even write if statements and have just a whole bunch of if statements. If this thing is null, if that thing's null, if this is null, if that's null. Horrible. What this fix does is it tells us on the one line what was the thing that was actually null. So let's go to one of the other things that I also do on these READMEs is I also tell you how to use the module. So I have a JUnit 5 test here that we can run. Or I could also say just run this class. So I'm going to run this Untitled example to demonstrate. Actually, let me open the source code first so we can see what the source code looks like. So we know what we're looking for. Here's my calculator class that will be called by the Untitled example. In my calculator class, I have a compute function, and it simply takes 3 long values, multiplies them together, and returns that as a long. Again, really basic, meaningless code, but it's useful for showing what happens here in the Untitled example. So in my main, what I'm going to do is I'm going to set up 3 variables, x, y, and z, and they're all going to be atomic longs. Now, the reason why I'm using atomic longs is because atomic longs, I can make them null. And they have these nice get methods that I can call on them. Now, obviously, you wouldn't write code like this because you'd be like, well, it's always going to be null. That's stupid. Yes, it is. But for purposes of demonstrating how this null pointer exception enhanced messaging works, this was a valuable thing to do. So we're just going to have some log messages that say, hey, we're in the normal execution flow. And then the next log statement, we're going to actually try to execute this thing, and it's going to throw a null pointer exception. We shouldn't see the computed value is because the actual exception will be thrown, but we will actually get to see what that new message looks like. And sure enough, we get the message, and here it is, normal execution flow. The next log message is going to call. It cannot invoke this method. And the reason why it can't invoke this method is because y is null. We as Java developers have never seen this. This was not available in Java 8. It wasn't available in Java 11. It would have been so much nicer if it had been. Now, one of the things I was thinking about earlier this week, and I was kind of curious, so I actually changed it just a little bit. I added a method in here. Let me do a public static. I'm going to return, let's say, an atomic long value, get value. I'm just going to return a null from here. But one of my questions that I was kind of wondering about is, what if it told me y was null? Okay, I know y is null. What if it's a function call, not an actual variable? Will it tell me the function call that caused the problem? So here I am calling my static method, and I have to get the long value from it. Okay, great. So, and that's just IntelliSense being smart and going like, hey, this is going to blow up. Yeah, I know it's going to blow up, but I still want to see what the message looks like from the generated null pointer exception. So I run the code. It gives me the same normal execution flow, the same next log statement will call function. But now here, when it says that it cannot invoke the atomic get long, because the return value of, check that out, it does actually tell me what the function call was that caused the null pointer exception to happen. So it won't tell you just, that a variable was null. It will also tell you that, hey, the function you're calling is returning the null. This is the thing that's the problem. You got to go figure out what's wrong and fix that. So this is the null pointer exception enhanced messaging. And I think that pretty much covers that. At this point in time, Jason, are there any questions anyone is asking about days periods or null pointer exception?
Nothing that hasn't been answered.
Okay.
We had someone ask what 5:45 a.m. would be, and responding back, it says it's in the morning, which, yeah, those times are, a little bit subjective as far as what people consider in the morning or afternoon or whatever, but that's what the spec is.
And that is a good point to bring up. It is a bit subjective. You can write classes that will override the default behavior. Like I said, it gets a little bit deep. It's a little bit complicated to figure out how to do that. But there is an opportunity to do that if you take the time to figure out how all the wiring happens. You can actually substitute in your own periods of the day to replace what the default is that comes with the CLDR fix. So that is a good point. Thanks for bringing that up. So For our next thing, I'm going to close up a few of these other module things. So try to keep clean as we keep going. Otherwise, I'll wind up with 50 different windows. Pattern matching instance of. Now, this is a boilerplate saver. How many times have we written switch statements where we have to, let's see, do I have an example here in my, yeah. So this is an example kind of highlighting what we usually do with our switch statements. We have to figure out if the object is this instance, and if it is an instance of that thing, then we are going to do that. Or we could do a try catch and handle the class cast exception. And then we call the function on moo. Well, it seems kind of ridiculous that I should do that if I already know what that object is. So what pattern matching, for instance of, is doing is it's reducing this boilerplate code that we always have to write, where you have to, in your case statement for the switch, you have to say, is it this type? Cast it to that type. Now we can use it. So instead, what we do for pattern matching, and the way it looks a little bit different, is we do this. We say, is the object an instance of cow? And we give it a name. So what will happen under the covers is we already know it's a cow. Go ahead and convert it to a cow object, and then we can immediately use the cow API. So we don't have to do this casting anymore in Java 17. We can use the pattern matching. So to use this example, we're going to go to the sound renderer test, and we're going to see that it exercises the get sound object. So let's go to our test class. And just for you to see, I have a car, cow, explosive charge. I have a few classes. Obviously, they are not anything exciting. They're very, very basic. And it makes the car makes a sound. The cow can do a moo. The explosive charge can do a detonate. But in terms of, exciting objects with, all sorts of great behavior, there's nothing exciting here. But in the test class, the sound renderer class, what I'm going to do is, in my method, I'm going to call, so the actual test method says, give me what the object is, and then give me what the expected sound is. Now, the object can be a car, a cow, an explosive charge, whatever, and the expected sound is going to be that. Now, I call the sound renderer get sound, and it's the same method call on each one of these objects, and it should match what my expected sound is. So we run this class. And, oh, what happened? Oh, setup must not be private. Why is setup private? I'll fix that. Just make a package private. See if it likes that better. And there we go. So it executed each one of these tests perfectly. The car went vroom, the cow went moo, the explosive charge went boom. So we got the sounds that we expected, and all I had to do is just pass in the object. And the pattern matching, whoops, a little too far. the pattern matching was able to reduce or help me eliminate having to do this mess of boilerplate code for each one of those objects. And instead, I was just able to just naturally use the API. Once I know what the object is, the API was just immediately available. So that
don't forget to commit and push. Your
oh yeah, no, don't worry. I already knew going into this, I'm probably going to find some problems. So they're just all going to be here in my Ubuntu session. And when I'm finished with the presentation today, I will go ahead and, well, I might not push this one. This one was the uncaught exception example, was me adding that private static method, or the additional static method to show that a method name would be in the exception message. I probably won't push that one, but I will push this one for sure. So yeah, I'll be taking care of that after this. But this is what the pattern matching, for instance of, does in Java 17. It just helps us to eliminate that boilerplate code, because the thing that's obvious is if you're asking, are you an instance of this thing, and you get a true back, go ahead and cast it. Like, we already know what it is. Just cast it for me and let me start using it. And so that's what the pattern matching instance of is all about. Any questions on that one? Nope. Okay.
Nope. No questions.
Great. Then let's go on to, let's see, records. I'm excited about this one. So how many times have you as a developer written a POJO, plain old Java object? You needed it to be immutable, and you just wanted to hold a few attributes. But in order to do that, you had to write not only the definition of your attributes in that POJO, you had to write your constructor, your getters, maybe a toString, an equals, a hash code. You wound up with all of this code you have to write because you just simply want to hold on to 2, 3, maybe 4 values in a POJO that's immutable. Well, finally, they've addressed that with the record classes and interfaces. So you can define any class or interface as a record because they added the record keyword to the language in Java 14. So there are a few things to know about the record classes. They are always final by definition. You cannot have something defined as a record and have it be abstract, as an example. You don't have to implement equals, hash code, or toString. They are implicitly already built for you. You can override them if you want, but that's a choice that you're making to just simply, you want a toString to represent it different visually when it's printed out. You can do that. That's fine. But you will get a meaningful toString. It won't just be the object name @ and then a hash code of where the object is in the heap. You'll get a meaningful toString. So to use this method, it says use the records test class in the example package and observe the assertions pass indicate, and we're going to look at the test to see we're validating that the equals, the hash code, and the toString all are giving us what we would normally expect. But first, let's take a look at what the actual record might look like. So I wanted to go with something that's a little bit more complex. So what I did was I took an address, a name, a person, and a phone number. And when we look at an address, we see, oh, you've got like a whole bunch of different kinds of strings. You have your street 1, street 2, unit, city. Some of these might be null. Okay. But look at how easy it was to define that. That's my record. I'm done. I've fully defined what an attribute. I don't have it. I don't have to say in a constructor, here's what the assignments are. I don't have to define what my getters. The getters already exist. Same thing for a name. For a person. Oh, and the person kind of pulls this all together. So you have a name, an age, a phone number, and an address. And so, and then for what I did here in phone number, it's a record. Phone number is a record. But I obviously had a thought, maybe I want to see the representation of this phone number in something that's a little bit more what I'm used to seeing with this kind of, the prefix, the dash, the or the area code, the dash, the prefix, the dash, the number, and maybe an extension, or type. What is? Oh yeah, type. So home, mobile, work, whatever. So this is just to demonstrate that I can override the toString. I don't have to take what's there, but this is just a choice that I make when I'm implementing a record. So now that we've looked at those classes, probably won't need those anymore. What we are more interested in is the actual test class. So here we go. So we come in here, the first test, we're going to validate that the equality, the equality. So we're going to build a person. We'll take so if we jump to that, this is what building a person looks like. So I come up with a specific address. Notice that the street 2 is null here. I'm obviously going a little bit local here with South Jordan. The phone number, giving a mobile phone number, the name, and the person. So now I'm going to take these things, and so I'm returning this person. And what we're going to do is we're going to test the equality of a person. And when we test the equality of a person, one of the things that I do is I built the same person 2 times, but I give a new phone number to this third person. So I expect that person 1 is going to equal person 2, but person 1 should not equal person 3, and person 2 should also not equal person 3 because of that new phone number should be different between those records. Or
hey,
record
we've got a question, Steve. If you want to take
Okay.
it now, great, or we can do it after.
I'm happy to take it now.
Test. Okay. So Michael Green asks, can you compare and contrast records with Lombok? When might it be better to use one or the other?
I don't know. I haven't done enough with Lombok to compare to see which one would be better or not. It's a great question. I just don't have a good answer for you. And it might be that Lombok actually solved the problem before records were even available. And maybe records are now the way to go forward. Or if you already have your Lombok code and it works, don't change what works. But I don't actually know for sure.
Yeah, I'm not sure on that one either. Although from what I remember with Lombok and records, they're both doing the exact same thing. They're both doing some bytecode manipulation at compile time. I would be surprised if you end up with the same class, but you probably end up with something very, very similar if you were to decompile the 2 classes and see what's actually there.
I agree. It probably looks very similar. I would also be shocked if they were exactly the same, because obviously Lombok was around before the records, and but I think that records are just a long overdue enhancement to Java 17. It's like, thank goodness we have them now. And this is a really great reason to go to Java 17, because you could see the definition of the records. Once you know what your POJO needs to be, what the elements are, the types and the names of the things, it's so easy to define it. And then everything is just automatically for free. And how much do we love that as developers? So that's a great question about Lombok. I think that they're very, very similar. I wouldn't say they're exactly the same, but they might behave in very, very similar manners. And it might just be the records is the Java finally catching up to where Lombok had already been previously. But we do test the quality. Then we test hash code. So I'm doing the same thing here, building person 1, build person 2. I changed my new phone number for person 3. And I'm just asserting that the hash code for these objects, they're totally different objects, but the hash code for those objects should be the same if all of the attributes are the same. And if the attributes are not the same, if they change in any way, I would expect the hash codes to not match, which we should see when we run that. And then finally, for the display name, we just get strings back. So we will be able to see, yeah, this is long and ugly, but this is what we would expect a person string to look like. And one of the things to notice is very specifically look at the format that we're expecting for that phone number. So when we run this class, we can see in action that where we expected the records to be equal, they were. Where we expected the record objects to not be equal, they asserted properly in that case. Where we were looking for the hash code, the hash codes were exactly the same where we expected them to be. And again, the hash codes were different where we expected them to be different because we knew that we had different values in the record objects. And then finally, that long, complicated toString, we were able to validate not only that the toString, that it publishes properly, but also that customized overriding the toString for the phone number worked exactly as we expected it to. So, obviously, I was not prepared for the Lombok question. Are there any other questions regarding the usefulness of records? And actually, did I say anything in here about Lombok? And no, that would have been a nice thing to have covered and have added here. It's possible
well, maybe you can add it later. We've got some people asking about the builder pattern and how that works with records and whatnot.
Yeah.
Oh, here's another question. So yeah, talk about builder patterns, and then I'll ask the other questions actually in the question section.
All right, great. So builder pattern. I have not played with that, and that's a great question because the way that we define the record, we are just simply providing, I would say you probably could do a builder pattern. I haven't actually done it myself, but the way I imagine that would look is, so you look at my record, I would go ahead and have some kind of builder, and I would have the builder have all my set methods. And when I call build on the static class, it would call this, this constructor. Now, I'm not sure if I can make that private. Let me see in the README if that's allowed to be private. The constructor and accessors are implicitly defined. So the constructor and accessor methods. Well, let me see if I can do it right here. Private. Will it? And IntelliSense is saying, I cannot provide a private here. So let's see. Can I make it? Let's see. 2 related problems. What are they? Usage in the import. Okay, that's fine. I expect that. So yeah, so provided that you do all your scoping, you could make a package private, which isn't normally what we do for our constructors. But remember, this is not an actual constructor that we're providing here. This is actually the definition of a class. Remember that the constructor is private. I would imagine that we could do an override of the constructor within this class. So that might look something like, whoops, went a little to get that guide come down. So I'd imagine we could do something like maybe private address, and then let me take all these things. And is it make address public? Canonical constructor cannot be more. Oh, okay. Because it's a record, because the constructors must be are defined by default, and it's public by default for a record, I cannot be more restrictive in my scoping. So I cannot so I could override the behavior of what a constructor does, but I cannot make the constructor more constricted than public. So you would have to be okay with the constructor being public, even though you're using a builder pattern. But would the builder pattern work? Absolutely. Sure, it would work, because when you call build on the builder class, it's just going to wind up calling the constructor exactly the way that we were calling constructors directly here in the class, in the test class. You would be, but instead of doing this, you would have, new address builder, new phone number builder. You would set your type, your area code, your prefix, your number, and then say build. But within the builder inner class, it would actually call the phone number, but you're not going to be able to make that constructor for a record more constricted than the public that is defined by default. So that was the one part about builder pattern.
Yep. All right. So this next question is, and this one should be a quick yes or no. Can a record implement an interface?
Yes, it can. That was part of, let's see. Well, I don't have an example of it. It's a great question. But when we come over to the Baldung and we look at the record keyword, we do learn that they do have this defined for interfaces, public class, string. They talk about the constructor, the getters, the equals, hash code, constructors. I feel like I saw it somewhere.
We've got some nice chat happening, and one of the things that Kyle mentions over here, which is good to know.
Okay.
Records extend the record class, so you can't do your own extension of a record itself.
No, but that makes sense, because when we go back to, let's see, I'm screen share. Oh, wait, that wasn't the thing I wanted. Let me get back to my IntelliJ. There we go. Because when we talk about record classes, remember that the actual objects are final by definition. So you can have a record that contains other records, but you cannot have a record that extends a record. And the reason why is because every record is final by definition. So yeah, of course, extending wouldn't work. But in terms of seeing a record interface, I haven't played around yet with that. I don't have an exact answer. I'm not sure that would make sense to have a record interface, because one of the things that the record keyword is doing for us, it's building all this boilerplate code, the constructor, the accessors, toString, all those things for us. So defining an interface as a record, I don't know that makes sense, if it is even allowed. My guess would be it's probably not allowed. I probably should remove that, but I'm going to do a little research after this presentation, And if I should be removing that, I will absolutely remove and interfaces and just talk about record classes. It's a great question. I don't know. I will find out. I will update this appropriately based on what I find out after this presentation. Any other questions about records? We talked about builder pattern. We talked about interfaces. We talked about extending record classes, which is not allowed.
Nope, I don't see any other questions.
Okay, fantastic. Thank you for that.
Let me check YouTube real quick. Nope, you're good.
Okay, great, thank you. So records are a really awesome boilerplate thing. So we're now going to come to sealed classes. It took me a while. Now, I do know for a fact you can have sealed classes and you can have sealed interfaces. I have examples of that in the code here. It took me a little bit of a time to wrap my mind around it. And if you'll notice that sealed classes were previewed in JDKs 15 and 16. It was finalized in 17. It's part of the Java Enhancement Proposal 409. And there's a really nice talk about sealed classes in Bow Down. But what we're doing with sealed classes, why is it called sealed? What does sealed mean, right? So what we're really talking about here is normally when you've defined an interface or a class, anyone, anywhere in the system that has access to that interface or to that class can implement that interface or can extend that class. Absolutely anyone. There's no restriction on that. Well, sealed classes, as of Java 17, allow you to constrict that. You can actually define exactly which subtypes you are going to allow to extend you as a class, or which interfaces you'll allow to extend your super interface, or which, let's get into some examples. So let me go ahead and close that. And so to demonstrate the usage of the new permits keyword, so we have this new keyword called permit. We're going to use three colors, blue, green, and red. And they're going to extend the abstract color class. And then we're going to have these four shapes, circle, rectangle, square, and triangle, which will extend the shape interface. So we're going to have colors and we're going to have shapes. But we want to note that a square is obviously a subclass of rectangle, but the square class also necessarily needs to implement the shape interface because the shape interface is sealed with a declaration to permit the square shape. So let's take a look at what that means. So we come over here to the models, and I separated out the colors and the shapes. So we're going to start here with the shape. And when we look at the shape, here's our new keyword, permits. So I have a sealed interface called shape, and it permits a circle, a rectangle, square, and a triangle. And so, you know, draw, color, rotate. These aren't particularly exciting, you know, methods. And the implementation of them will be, you know, so I just did some logging to keep it really simple for what draw, color. I didn't want to get into, you know, firing up an actual UI. The logging the information is enough to see what's going on. But if you remember, what that README was saying is that shape says you have a rectangle, and then you have a square. Now the square actually extends rectangle, but it still implements shape. So we still have to override. So even though we do extend rectangle's behaviors, right? Here are the behaviors. But square has to actually have implementations because it's defined by the permits keyword in our sealed interface. So that's what this cautionary thing was saying, is that, yeah, you might have this one class that's extending the other class, but because it's a sealed class, you still have to do your implementation for that thing because it's sealed. Let's see. And then there was also another cautionary note. It's also worthwhile to note that the classes that either extend a sealed class or implement a sealed interface necessarily need to declare that class as one of final, sealed, or non-sealed. So you don't really have an option. You have to, the class must specify one of these things. And that's something that was actually done here in Square. It's final. Rectangle was sealed. Notice that rectangle was not final because I wanted to extend it. I did say rectangle is sealed, but it's not final. So that's one of the other things you have to pay attention to when you're using the sealed classes and interfaces. You do need to pay attention that you need to define the class, the sealed class, as one of these three types. So, and then if you want to look at colors real quick, there's nothing particularly fancy here. Color is also, it's an abstract sealed class, but it permits blue, green, and red. And all blue does is it says I'm blue. Green says I'm green. That's all it says. Like, absolutely. I try to come up with the dumbest, easiest, simplest models because the models aren't what we care about. It's how they get used and how they behave that we actually care about. So to use this module, the execution of the main program is honestly quite boring. The truly interesting part of this module is looking at the model definitions. Okay, so we did look at the model definitions. Run the create manipulate shapes file, and then we'll see log output. Okay, so we run this guy. And we can see that we're going to start with the circle. So it says drawing the circle. My color is blue for the circle. Coloring this circle blue. Rotating a circle 90 degrees still looks the same. Now let's do a square. So these are just the behaviors that I wrote into the individual model objects so that we could see that when we call those methods, they execute. But what you cannot do if you wanted to is you would not be able to define a color purple because color does not allow for purple to extend. Purple is not allowed to extend this color. So you would have to actually change colors definition to include purple, brown, yellow in order for those colors to be, those classes to be able to be created and then do their thing. Same thing for the shape. If you wanted to come up with a rhomboid, you would not be able to have a rhomboid without changing the definition of this shape interface. But this is how we use the sealed and the permits keywords. And then there are just those few caveats to know about the requirements of having, wait, where was it? Yeah, there you go. The requirements of having these keywords in your subclasses that are implementing or extending your sealed classes and interfaces. So any questions there? It's just simply, sealed classes are simply a way to lock down who can extend or implement, who can extend your class or implement your interface.
All right, so we've got a question over here.
Okay.
Does violating a seal/permit result in a compile error, or is it a runtime error?
No, it's absolutely you won't be able to compile. It's going to say, it's going to give you an error. It's going to say, you can't do that. That's not allowed. In fact, let's go ahead and do that. Let's say I'm going to implement a color shape. Let me do new Java class. I want this to be purple. No, I'm not going to add it to get but I am going to extend color. I'm going to make this final. And it's giving me an error here. What's the error? There is no default create constructor. Okay, great. Matching true. Wait, it's saying, oh, purple is not allowed in the sealed hierarchy. Add purple to the permits list of the sealed class. So it is a compilation error. It is not a runtime error.
Perfect. We might have just hit on this follow-up question, but I'll ask it anyway. Does a subclass of a sealed class that labels itself as non-sealed mean anyone can extend that subclass? So he's trying to figure out the point of non-sealed.
Yeah, no. So it's well, let's see. So because we do have a non-sealed class, right? We have the rectangle. So remember, here is the let's see. That was, oh, gotcha. Okay, no, it wasn't. So let's say that this is non-sealed. No, oh wait, non-sealed. There we go. Oh, because I made it, because it permits square. So, well, let's go ahead and check this out. Let's see, we're at 710. I'm at sealed classes. We still have switch expressions and text blocks to go. I think we can do that.
Just keep going.
All right, great. So let's see. So we're going to add this Java class. I'm going to do let's see, rhomboid. Let's see. I'm going to make that. Let's see. Let's see. Don't add it. Call that non-sealed. Okay. And then extends or implements shape. Okay. And the first thing it tells me is I got to implement some methods. Fine. Go ahead and implement them. Now it's going to complain, well, you're not really defined. Okay, so let's go ahead and change shape. So, okay, so now I have a non-sealed class called rhomboid. And let's see, I don't really need an implementation for any of that. But let's see what happens now when I extend rhomboid. So rhomboid 2, the class, and I'm not going to extend that. Extends rhomboid. And he says rhomboid 2 is never used. So it looks like I don't get a compilation error here. Looks like I could define any kind of constructor I want to, any kind of methods I want to. It'll inherit from rhomboid, but it doesn't look like it is now in any way limited by sealed class. So I made an intentional decision when I put non-sealed here on the rhomboid. Any code that wants to extend that class is welcome to do that. And I have broken the sealing process at that point. And I guess that's why they provided the difference between sealed and non-sealed. The moment that I put the non-sealed there, then rhomboid 2 has a problem because he's not allowed to do that extension of rhomboid. But the non-sealed totally allows me to do that. So, question answered?
Yeah, yep, I believe so. So we've got another one here.
Okay.
Does the package matter? For example, if I create a green class in a different package, would it work?
Well, let's do that, right? So I'm in a different package. Obviously, this is horrible design. You would never ever want to do this, but have the same class.
And one of the other things where things get really kind of tricky and whatnot, if you combine this with modules from Java 9, things get all sorts of funky.
Oh, yeah. Yeah. Now, for that, I'm not going to be able to have any answers for you guys because I haven't actually done. I'm obviously doing everything in the unnamed package. So, but let me see. Seal, or actually, I'll make this final over here and then say extends color. And it has to pull that guy in. And now there's no default. So create the constructor, okay? And then color. So it's not allowed in the sealed. So it's not allowed in the sealed hierarchy. Being outside of the. So I'm in shape. I'm not in color. I'm in a different package. And being in a different package, it says green is not allowed in the sealed hierarchy. It sure is over here, but it is not over in this package. So going between packages is a no-go. It breaks the sealing and will be a compilation error.
All right, I think that will do it unless we get a question later on. But let's move forward.
Okay, great. 15 minutes. I think that's plenty of time for the couple things we got left here. So that's what sealed classes are all about. Let's get rid of that one. And then come down here to switch expressions. So if you listen to Uncle Bob says don't use switches at all. That's horrible. Use polymorphism, have different types for your things. But if you're like me, you only listen to some of what Uncle Bob says, not all of it. And if you use switch expressions, this is really cool where what's going on here. So this came out in Java 14. It was previewed in 12 and 13. So this was early on in the journey from 11 to 17. We don't need the break statements anymore. How many times have you used switch statements? You wrote your case and you forgot to put your break statement in. So what it did was it just automatically flowed to the next case. And then, of course, you have to debug and figure out what's going on. Why is it doing all this extra stuff I don't want it to do? And you realize, I forgot the break. So what's happening here now is execution automatically flows through. This is what normally happens. So the switch expressions offer a safer way to use switch functionality because they don't use the break keyword. as each evaluation yields a specific return value. So it's this yielding that makes it a switch expression and not a switch statement. So what does that mean? Let's go and take a look at, let's look first at definition of some code. So here's what my quarter enum looks like. A Q1, Q2, Q3, Q4. We're all used to fiscal years and how they break down into quarters. And I also have a string value for each one of these: first quarter, second quarter, third quarter, fourth quarter, blah, 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 blah. And it can print all this stuff out. Now, you look at my static method here from month. I can pass any month I want, any month of the year I want. In these cases, I want it to yield Q1. In these months, I want it to yield Q2. In these months, I want it to yield Q3. Notice that there are no break statements here, but this is absolutely, without question, a switch expression, not a switch statement. Okay? So, and then here's your switch statement. This is the same class, but we're going to do that with a statement. So here's what the switch statement looks like. This is what we're used to. This is what you would do in Java 11, right? So if it's one of those, do that, but here's my break. Do one of those. This is what the value is, but here's my break. And then at the end, return quarter. Fine, but how much easier is it to read this, right? So we come over to our test, and we're just going to test to make sure that we get the right thing for the right quarter for the right months. So here are all my months I'm going to test. I'm going to test January through December. And I'm going to expect these very specific Q1, Q2, Q3, and Q4 values to come back, because that's what that method should do. And when I run it, all of my cases, so proper conversion from April to second quarter, from August to third quarter, from July to third quarter, from May to second quarter, October to fourth quarter. So it's properly converting all of those without using the break keyword, because this is a switch expression. So it's this yield sign. Now you might look at it and say, well, that's a lambda. No, it's not a lambda. It's a yield for the switch expression. Similar syntax, but different meaning. But when we see case, and then we see the syntax, we know, oh, it's just going to simply evaluate that to that thing and return. That's the value that gets returned. Cool. But no breaks are necessary. Any questions here?
Doesn't look like it.
Okay.
I had one, and I think I answered it myself, but just for anyone else that's interested. So there are some cases, now there's not a lot, but there are some cases where you want a fall through switch. The difference here is that this is for just a statement. It's not a block of code. It's just a statement, the same way that you would end anything else with a semicolon.
That is a good point. You are still going to want your statement when you want to do a whole bunch of things. When you're just simply evaluating to one value, this is a much better way to go in Java 17. But as Jason pointed out, yeah, if you need to do go get this value and then do some manipulation, modify it, check if this thing or if that thing, you have some conditional logic in there, you have a whole block. Yeah, you're going to want to still stay with your switch statements. And switch statements haven't gone away. We just have switch expressions now that are added to the language, because there are a number of times when we are writing code that we just simply want to evaluate to the one value. that makes sense. Thanks for bringing that up, Jason. So the last module I want to talk about, and then we can get to the future of Java things, is text blocks. And I think this is cool. I love this. I wish they'd had this in Java a lot sooner. So this was introduced in Java 15. It was previewed in 13 and 14. Java Enhancement Proposal 378, multi-line strings. So how many times have we written multi-line strings with all this ugly syntax? Let me see if I have an example of what that ugly syntax is. I think I do. Let's see, the model. So there's a model. Create and serialize person. Let's see. Okay. Oh, I might have done it. Okay, so we're familiar with the model I had from before. So these are just simply classes. I made these as JSON serialized classes because what I'm going to use now is I'm going to use the Jackson library. I'm going to deserialize some data, but it's not the deserialization that is the focus of this example here. What we actually want to, and then let's see, create and serialize. And so this just creates a person. So it sets a whole bunch of stuff, uses the builders, and it just simply serializes a person. That's fine. But what we are going to focus on here is, whoops, let me get to that test method. What it looks like. So this is the pre-text block. So this is how we would have done a multi-line string to be tested today, right? In Java 11, Java 8, even in Java 16. This is how you would do it. Well, actually, no, because this was introduced by Java 16. But you have your string, and then you do a plus, and then you have all this stuff, and you have all these escaped double quotes in there. So really hard to read. Those end of line values, and then having to escape but you have to do that because you only have a single quotation mark. And so then you have to append all of that stuff. Now, if we run this test, it passes. So what are we checking for? I'm just checking all the values. I'm validating the name, the age, the phone number. I'm just validating all the parts of that the deserialization happens properly. And if I run this, yeah, fine, it works. But here's what text blocks give us in Java 17. How much easier is it to read and modify this data? There's your sample JSON. It could be JSON, it could be XML, it could be code, it could be whatever. The point is that's multi-line. It contains new line characters in it. It contains double quotation marks. What makes it a text block is this notation. We have the triple quotation marks there and the triple quotation marks here to end it. And so this is a string. Now, it's a string object. You can do with it every single thing that you can do with any string object. All of the string API still applies to this person JSON, but modifying this multi-line text is just it's so much easier to read it. It's so much easier to maintain it. And so the test is the same test. It doesn't change at all. And then this was some stuff I added in, just testing the indent before using an indent, and then after the invocation of an indent. So this is just showing you what happens when we call various string functions. There's a string function called .indent, and we can do things, and it actually, gives us, it's just a string object. It works fine. So if we run this class, or the JUnit 5 test, Testing indent on a text block works absolutely just fine. Before the indent method, after the indent -5, and after the invocation of indent 20. So you can see what all those look like. And this guy just passed. Everything deserialized fine. So it's not a complicated thing. It's not like, oh, wow, I really need to wrap my head around it. It's just a syntactical thing that I think, syntactical sugar that I think is really nice to add to the language. Any questions here on text blocks?
Nope, no questions on text blocks. We got some smiley faces with hearts though. So I mean, it's
Nice.
one of those where it's about time. You know, other languages have had things like here docs and whatnot for ages.
Oh, absolutely. I agree 100% with you guys. Long overdue. I'm happy it's here. You get it when you go to Java 17. And oh yeah, one of the things I forgot, if you have a multi-line SQL statement for a prepared statement instance, multi-line SQL, a text block could be wonderful to add in. You can still do your variable substitutions and all that stuff for a prepared statement. Like I said, it's a string like any other string, but that could work really nice. So yeah, you got this thing to play with too. So text blocks. So that's pretty much all the modules. I'm going to come back over to, if I can find that thing. All right. So again, like I said, this PowerPoint presentation is going to get out there somewhere. Jason will help me figure that out. And then you can just git clone this guy and play around as much as you want. I will push that one change that we had done out there. So now let's talk just in the last few minutes what's coming. Nothing's promised, right? You can't ever say for sure this is going to be in the next long-term support release. There are some things we think we might see. Obviously, we're a year out. This is September 2022. 2023 is when they scheduled JDK 21 to come out. That's the next long-term support.
Well, we've got a question about text blocks that came in, Steve.
Oh, okay.
Yep.
What's that?
So will text blocks work inside annotations like Spring or JPA's at query?
That is a great question. I don't know. I haven't tried them out. My expectation would be that they would work fine. And the reason why is because a text block evaluates to nothing more than a string. It's a multi-line string, but it's still a string object. So as long as the annotation is looking for a string object, I would expect it would work, but I haven't tested it, so I'm not positive.
Perfect. Thanks.
You're welcome. Great question, though. Didn't even think about that. So things that we are looking at is, if you remember the pattern matching instance of, they're looking to do a very similar thing for pattern matching on the switch statements and expressions. So when you want to, so when you're in a case statement on a switch, well, if you already knew what the object was, then just be able to make use of it. You shouldn't have to go casting. So whatever this pattern matching switch statements and expressions, that might be coming in JDK 21. They were talking about that. The default character set for today, oh, I can't remember what it is. It's not UTF-8. It's some Windows, default character set, some Western type of character set. They are looking at making UTF become the default character set in JDK 21. So that'll be interesting. We already talked in a good bit about the common locale data repository for the datetime pattern. That B annotation was, or symbol, was just one. But they have some other ideas about ways that they want to enhance the datetime pattern and do more for the datetime pattern for internationalization. So they're thinking that there's going to be something more. They did the JDK fix for Java 17, but they're thinking that there's going to be more coming in JDK 21 to be more complete for internationalization. This one's kind of interesting. Any of you that have ever worked with JNI, Java native interface, know that it can be really complicated and difficult to work with. They are looking now at developing a foreign function and memory API. So what that means is you would get like some classes in Java that you would use to invoke native code, native functions in other languages. And the thing that would be useful about that is because it's an API, they will be able to have exception handling and guards around accessing memory that you don't have access to from the JVM. So it could be a lot safer than just writing your native Java, your native JNI code, which is pretty unsafe and kind of risky. You really need to know what you're doing when you do JNI. They're thinking the foreign function and memory API will be a lot safer than JNI and a lot easier to be able to access functions from other languages and available, in the kernel or available in the operating system or through shared memory or whatever. Re-implementation of the core reflection. So reflection really hasn't been redone for a long time. The method handles that they're talking about, I don't know exactly what those are, but they're talking about a re-implementation of the core reflection libraries to make them a little bit easier to use and perhaps even a little bit more performant than what they are now. The simple web server, any of you that have done web development, you know that you've used the Jetty server or you installed Tomcat and you had to spin up a whole web server to do your things. They're thinking that for development, that's pretty heavy and you don't need to have something that heavy. We should be able to spin up a really simple, easy web server, like almost no cost, very lightweight, easily configurable, and be able to test our web code. So they're looking at, can we provide some kind of simple web server in the JDK? So that might come out perhaps in JDK 21. Project Loom, if you haven't followed it, it's virtual threading. So instead of like bombing out on memory after you try to create 10,000 actual threads, you could have 10 million virtual threads. They're all way faster. It's all in memory. I mean, it's just memory. That's all a thread is just, picture memory when it's a virtual thread. And Project Loom has been in the works for years. They have been very careful to not schedule it for any particular release of Java because they've been doing a ton of work for a long time and they don't. It takes a lot to implement threading safely and properly into the JVM, and they're not going to introduce it until it's ready. Trying to fix an error in threading, good luck. So they're being very, very, very careful with Project Loom, but there's a possibility. I heard there was some mention it might be coming in JDK 21. And then Project Valhalla is really interesting. User-defined primitives. So yeah, we all know int long, string short, float. But having user-defined primitives and value objects, they're looking at how can we extend the language in a safe way so that users can define their own types, native types that will value objects and user-defined primitives essentially will give you performance enhancements, performance boosts by whatever architecture, whatever design they're doing. I don't know a whole lot about it, but I can tell you there's a lot of information if you go out looking for Project Loom, Project Valhalla. And Jason mentioned at the beginning of the talk, there's Project Crack, who we're going to have someone talking about that next month in October. So there, what's going to be in Java 21? Who knows? We have a lot to see. Java 18 is out now. It gives you a little bit of a hint what might be coming, but there's a lot more to come in Java 19 and Java 20 before we get to Java 21 next year. But with that said, I think I'm at time. And are there any outstanding questions for me that we haven't already addressed along the way about Java 11 to 17, the new features in Java 17?
Not seeing any questions yet, but if they come in, I will definitely let you know. And I'll pull myself up here. All right. So those that are still here, so this is one of those must be present to win kind of things. We'll go through our the raffle that we've got. So we've got Venkat's Agile Learner 1-year subscription and 2 JetBrains licenses for any of their IDEs. So if you're interested in any of those things, stick around. Excuse me. Stick around, and we'll raffle those off. So I'll leave just a couple of minutes for questions if questions have come up. And again, be sure to check in with us next month. So we're talking about Project Crack, and then to finish off the year in November, we're going to be talking about majestic monoliths. So when you would want to do a monolith versus a microservice and whatnot. So that should do it. All right. I don't have any questions. Oh, nope. I say that and one pops up. All right, let's see. Can I use annotations in a record definition?
That's a great question. I don't know.
Don't see why not.
Oh, Doug Erickson said, yes, you can.
Yep. All right. Well, there we go.
Thank you, Doug. Yeah, it would make sense that you could, because you're defining a class, and the only thing that's different about it is that the syntax of it, you're putting in the definition of the class, here are the objects and object types or here's the names and the object types I care about. So, but it would make sense that, yeah, annotations, sure, why not?
So where can we find Steve's slides? Steve has not given them to me yet, but what I think we'll do, Steve, if you can post them up somewhere, and then we'll just put the link up on Meetup. Or
okay,
it's been a little while, but I think we can actually upload things to Meetup. So if you want to do like a export as a PDF or something like that, then we can do that as well.
All right. Do you have a way to notify the people who were here tonight to send the notification? Oh, I guess we'll post it in the discussion for the meetup.
Yeah. Yep. That's exactly what
we'll say. Go look here. Cool.
That'll work. All right. So for the 16 of you that are here, and actually I guess it's 15 because Steve, you count as one of them. If you're interested in Venkat's Agile Learner, I did not pull names or whatnot. So what I will need from you, and actually, well, let me pull down export to CSV. That's it. So now I've got everyone's email and whatnot. So if you're interested in Venkat's Agile Learner thing, the first person that responds to this one correctly will get it. So the first person to correctly submit Venkat's last name will win the Agile Learner subscription. All right, cool. Mahjong, you got that one. Let's start I need a new note. And kudos to you if you actually spelled it right and didn't Google it. All right, so for the 2 JetBrains licenses, for those that are interested in one of those IDEs, let me know what new feature from an IDE that you are interested in. Because I think we've just had a new version of IntelliJ come out, or we're expecting one fairly soon. This also saves me from having to ask people if they're one, if they're interested, and 2, if they're actually here. while people are sitting there typing their stuff. Thanks again, Steve, for coming out. You know, it's great to see the new things that are coming out in Java, and like you said at the very beginning, the cadence for releases for Java is going really well. When they first said we were doing releases every 6 months, I was a little bit skeptical, to be honest.
Me too.
You know, I wondered, how are you going to get everything out, because you were packing stuff full all of the time. But I think that this idea where as soon as it's ready, it goes out in the next release makes a whole lot of sense.
Yeah, and they're managing it really well too, in terms of, you know, here we're going to develop, here we're going to prepare for release, here we're going to release it, then we're going to get feedback, and then it feeds into the next release. And they're managing that process really well.
Yep. All right, so James and Hundra, you guys get JetBrains licenses, and we will get those out to you within the next couple of days. So that should do it. Again, thank you everyone for coming. I can't talk and type at the same time. I can walk and chew gum at the same time, but talking and typing at the same time, no worky so well. So once again, thank you everyone, and I'm glad that you all came out here and were here for us. We look forward to seeing you next month. Again, we're still going to be virtual as long as people are interested in staying virtual. If you want to do something that is live, definitely let us know. We're looking for that kind of feedback from you as a community as far as what you want. So definitely let us know. If you're curious about that, let me write this down. Or if you want to express your opinion either way, send us an email, board@ujug.org, and we'll take that stuff into consideration. So thanks again, everyone.
And thank you. Thank you to everyone for your time. It was a pleasure to put all this information together for you. And hopefully I'll be able to give you something similar for Java 21 in the future.
Awesome. Looking forward to it. Great. Thanks, everyone. Take care. And we will see you all next month. Until then.
Good night.